Hey, grade 10s. So we are now starting a new unit. We're on unit 3, which is learning all about quadratic functions. And in today's lesson, I think this is appropriate to start with this. We're going to start with properties of quadratic functions. So here we go. So again, learning objectives, pretty simple. We're just going to look at the key properties of quadratic functions, which I'm hoping I really hope that most of this is a review, right? Because you should have done this in grade 10, but if you have not, that's okay. We're going to review it again. And then we're also going to learn about how to find the vertex of a quadratic function if we know the zeros. And that will be really important to us. And you'll see that in unit 3, basically, we're taking a lot of the concepts from grade 10. We're just kind of expanding on them. So unit 3, in my opinion, this is just my opinion, I think it's one of the easier ones because I feel like there's actually not a lot of new material. We're simply kind of extending on what you did in grade 10. So hopefully it will be slightly easier than what we have seen already. So just a quick recap here. What are quadratic functions? So quadratic functions have three key properties. The degree or the highest exponent of the variable is 2. We also know that the first difference is not going to be constant, but the second difference, just a reminder, second difference is the difference between consecutive first differences is going to be constant. What I mean by constant, it basically means the same. So all the second differences are going to be the same. Now keep in mind the first differences are not the same, but the second differences are the same. So that is what sets quadratic functions apart from other types of functions, such as linear functions. And of course, its graph is a parabola, and that's probably the most obvious characteristic that we can see right away looking at a graph. So as an example, this function, f at x is 6x squared minus 2x is quadratic because its degree is 2. So we can see here the highest exponent there is 2. This has a variable with exponent 1. This has x to the power 2, and so we can see 2 is the highest degree. Sorry, is the highest exponent, so that's the degree. This one right here tends to throw people off because you might look at this and think, well, isn't the degree 1? Because that has degree 1, and sorry, this has an exponent of 1. This has an exponent of 1. But remember, it is actually quadratic because if we expand this out, so going back to FOIL, if we were to expand this out, and I'm actually not going to do it all the way, I just want to start it off, you will notice right away that if I expand this out here, I end up getting 4x squared. So I don't even need to complete this. I mean, I can expand this out and, do 4x times 2, which is 2x, negative 5 times x, negative 5x, and negative 5 times 2, and I can complete this by simplifying it, but I don't even have to do that. I just stop right there and I just focus on the highest exponent, which is clearly 2. So because the highest exponent there is 2, that means that that is a second degree function, which means it is quadratic. So this is another example of something that doesn't necessarily look quadratic right away, but it actually is. What about a table of values? So obviously on a graph, we didn't even go over that because it's pretty obvious. A graph, basically you can tell it's a parabola if it's sorry, it's a quadratic if its graph is a parabola, like that, right? But if you have a table of values, it's not always that obvious what it is, so you have to do a little bit more work, and it's not too much more work. So determine whether the table of values represents a linear or quadratic function. So going back to grade 9, if you recall, we can tell if something is a linear function by finding the first differences and then checking to see if the first differences are constant or not. So what we're going to do in this case is we're simply going to check the first differences and see if they are constant or not. So looking at this first two here, let's find the first difference. So again, this is a little review of grade 9 and also a little grade 10 because I think you did second differences in grade 10. So let's find the first differences. Our first difference here is 7 minus 4. And again, be careful the order you do this in. It's always the y value you have here minus the one before it. 7 minus 4 is 3. Then we do 12 minus 7. So 12 minus 7 is going to give us 5. And then we do 19 minus 12. 19 minus 12 is 7. And then we do 28 minus 19. 28 minus 19 is 9. And finally, we do 39 minus 28, which we know 39 minus 28 gives us a total of 11. So there are my first differences. So what do we notice so far? Well, we definitely notice it's not linear. I can tell you that right now, because if in order for it to be linear, all the first differences will have to be the same. So now what we're going to do is we're going to find the second differences, which the second differences are simply the differences between the first differences, if that makes sense. I know it's a little bit hard to think about sometimes, but basically the second difference is you're just taking the difference of the first differences and you're checking to see what it is. So now I'm going to be subtracting off this the first differences here. So we take 5 minus 3, and we can check. 5 minus 3 gives us 2. 7 minus 5 gives us 2. 9 minus 7 gives us 2. And 11 minus 9 gives us 2. So I think we can kind of see what's happening here. We notice that the second differences are all the same. So this is obviously going to be a quadratic function because the first differences are not the same, but the second differences are. So looking at this, again, this is just kind of showing you the answer. We can calculate the first differences we saw was 3, 5, 7, 9, and 11, which means that it's not linear. And then we notice that the second differences were all the same. So this is definitely a quadratic function. So there's different types of forms that we can have a quadratic function in. The first type that we can have a quadratic function given to us in is something called standard form. Standard form basically is when we write out the function as f at x is equal to ax squared plus bx plus c. And keep in mind that I can write f at x or I can write y, and you're going to notice that textbook will sometimes use y instead, and that's totally fine. So what do each of these parts represent? Well, the two that we're going to focus on are the leading coefficient a and the last term by itself, which is the constant c. So the leading coefficient a, and it has, I'll specify right here, it's called leading coefficient. It's called that because it's the first coefficient we see there. And again, you're going to learn more about this in grade 12, so I'm not going to stress too much about the terminology, but basically the leading coefficient is the first variable we see there, a. And this last one here is called a constant, and it's called constant because it does not actually have a variable attached to it. It is simply a number, right? And the number could be 0, by the way. So that the a value, what it does is it tells you whether the parabola opens up or it opens down. And keep in mind that a cannot be 0, because if it was 0, what would happen? This would actually not be quadratic because that wouldn't exist at all. So it would actually become linear. So we need to specify that a is not 0. The y-intercept, as I mentioned already, is also special. Sorry, the c value is also special because it tells us what the y-intercept is. And I don't want to go into too much detail about this, but I think most of you can probably see why that's the case. And I can actually write it here at the bottom. I can even show you with a small example. If I wanted to find out the y-intercept, and I think this would hopefully make sense, I would simply let x be 0, because we know we find the y-intercept by letting x equal 0. And when I do that, when I sub in 0 into the function, it's probably better if I do it like this. We'll notice that I end up getting a times 0 squared plus b times 0 plus c. And then what I notice is that this goes towards 0, right? This goes towards 0, and then I end up with just f at 0 equaling c. And by the way, you might notice that f at 0 equals c is very special. That's actually going to give you your y-intercept, and I believe, if you're not mistaken, so if you look back at your test, there was a question that was multiple choice, and it said, what does f at 1 represent? And in that case, it was written in vertex form. So what I wanted you to do was realize that if I write f at 1, I'm really just talking about the y value when x is equal to 1. So when I say f at 0, what I mean is what's the y value when x is equal to 0? And what we notice is that that y-intercept is simply going to be c, because it's the only variable we're left with when we let x equal 0. And again, going back to this, the a value is really important because it tells us whether our parabola opens up or opens down. And if it opens up, then it's going to be a minimum value that we have, because obviously if it's opening up, then we can only have a minimum point. And if it's opening down, we can only have a maximum point. Okay, so I hope that makes sense as well. And I think we discussed this already when we talked about domain and range of parabolas as well. So this is a really important concept to understand. So hopefully that makes it clear. And again, that's what happens when you look at quadratic equations in standard form. Next point, factored form. What if we look at quadratic equations in factored form? So in factored form, we have f at x is equal to a x minus r times x minus s, where r and s are the x-intercepts. So in factor form, what we do is we actually specify what the x-intercepts are. So this is going to be really helpful to us because if we know where the x-intercepts are, then we can have an idea of what the graph looks like. Standard form, to be quite honest, doesn't give us that much information because unfortunately, all you know is the y-intercept and you know the direction it opens and opens in, whether it opens up or opens down, but we still don't know exactly where the other key points are. So knowing the x-intercepts is actually extremely helpful, and we're going to look at some examples because if you know where the x-intercept is, you can actually use that to help you find the vertex, which is right in the middle. So the A is, again, going to be the leading coefficient, and it's still going to tell you this exact same thing. It's still going to tell you whether it opens up or down. So the good thing about it is the A that you found in the previous example is still going to be the same A value that we look at, right? And again, it opens up if A is positive, it opens down if A is negative. So let's say that we have, just a small example, the x-intercepts of a graph are 4, 0, and -2 and 0. So if the leading coefficient is 3, what is the factor form of the equation? So let's just write this out. Well, we know that our leading coefficient is A, so we simply write 3. And then our zeros, be really careful with this. My first 0 is 4, so I'm not going to write x plus 4, even though you would think that because it's positive. I'm going to write x minus 4. And the reason I do this, and I'll kind of explain this briefly, actually, I'll wait until I fill out the last one. And then the last example here, I have x plus 2. So again, remember that what I'm doing is I'm simply taking, and I'll show the steps here for this one. In factor form, I am simply subtracting off whatever the 0 is. So because I'm subtracting a negative x-intercept, this actually becomes 3. The form is going to be y is equal to 3 x minus 4 times x plus 2. So you're probably wondering, why is it that the signs have to be the opposite of what the zeros are, right? It seems like it should be the opposite way. Well, think back to what happens when we try to find the x-intercepts. To find the x-intercept, we simply let y equal 0, which basically means that this equation becomes 0, and then you end up with something like this. And then when you're trying to solve for the x-intercepts, what do you think will happen next? You simply let each of them equal to 0. So you set each of them equal to 0, kind of like what we did when we found the vertical, the restrictions on our function. Remember we talked about that? You have to let the denominator equal 0. And then what you notice is that when you move it over to the other side, the signs will change. So that's why in factor form, the signs are reversed, right? Because we know that when we end up solving for the x-intercept, we have to switch the sign around. So it's really important that you understand that concept, okay? For now, just focus on how to write it in factor form, which basically it means we're doing this. So we simply sub in our x-intercepts, and remember always opposite signs of what the sign of the 0 is. And then you end up getting y is equal to, or f at x is equal to 3 times x minus 4 times x plus 2. So I'm hoping that kind of makes sense so far. So what is the relationship between the vertex and the zeros? And again, I'm hoping this is review as well. You might remember this from grade 10. If I know what my two zeros are, let's say that they're right here, 0 and 4, I'll notice that the zeros are very helpful because they actually will help us identify where the vertex is. And the vertex is the highest or the lowest point on the graph. So the zeros will help us find something called the axis of symmetry. And the axis of symmetry is basically the vertical line that goes halfway between the zeros. So the line that goes the vertical line going directly between the zeros or the roots, sometimes call them roots, is going to be our axis of symmetry. And the vertex is basically on the axis of symmetry. That's all we need to know there. And then what's important with this is that the x-coordinate of the vertex, we can actually find it pretty easily because it's right halfway between the two zeros. And I'm going to call this one R, and I'm going to call this one S. You do a little bit of math. All you're doing is finding the average between them. So to find the point between them, you take R and S, you add them up, which is R plus S, and then you divide by 2 because you know it's going to be right in between them. And really, you don't need to use this formula, and I don't recommend that you memorize that. It's not worth memorizing, but I hope that you just start to know that just because you do it enough times, right? So really what you're doing to find the x-intercept of a vertex or the axis of the symmetry, because that's where the vertex is going to lie, you simply take the two zeros and you add them and divide by 2 because you're finding the midpoint between them, the halfway point. So once I know what the x coordinate of the vertex is, which is the axis of symmetry, that's what we're looking at, we can use that to help us find the y coordinate of the vertex. So to find the y coordinate of the vertex, we take our axis of symmetry, which is r plus s divided by 2, and we simply sub it into our function. That's really what we're saying here. You take your x coordinate of the vertex and you simply sub it into the quadratic function to find out what the y coordinate is. So I'm hoping that kind of makes sense so far. We'll look at an example. I think it's more clear with an actual concrete example here. So let's look at finding the vertex using zeros. So in this example, and I think the graph didn't come up. Sorry, let me just switch this around. Oops, yes, sorry. Let me start from the beginning. Okay, so identify the zeros. So first thing, we're going to be given an equation, right? And we're going to first figure out what the zeros are. So in this case, my zeros are going to be, and again, be careful with this, the signs always switch. So it's x minus r, right? So this is my r value, so it's going to be 3. And this is x minus s. So this is actually going to be an s, or an x-intercept of -5. So we have 3 for the first x-intercept and -5 for the second x-intercept. So those are my two zeros, 3 and -5. Now that I know what my zeros are, I'm simply going to find the midpoint or the halfway point between them. So I could use a formula for this, or I could do a little bit of math. If I know that my zeros are +3 and -5, I can even do a quick sketch here just to kind of see what it looks like. Here's -5, and here's 3. By the way, when I talk about sketch, it means just do a rough drawing, right? It doesn't even have to be perfectly labeled. It's just a rough drawing just to see what it looks like, okay? That's different than a graph. A graph means it has to be more detailed and it has to be labeled. In this case, I'm just doing a quick little sketch here just to help me out. So I know that the parabola is going to open up, by the way. And how do I know that? Because the a value is positive. So I know it opens up. I know it has a 0 of -5 and 3. So it's going to look something like this. Oops, something like that, right? And again, I don't know exactly what it looks like, but it's going to look something like that. So what I'm trying to do in this case is trying to figure out where in this graph could my vertex possibly be. Well, I do know that my vertex is going to be halfway between the zeros. So I have to figure out what number is halfway between 3 and -5. Now you could use a number line for this if you want to go back to a little bit of elementary school. You could definitely do that. You could do a number line and figure out what number is halfway between them. But I feel like not being in grade 10 math or grade 11 math, sorry, but in grade 10, I feel like it might be easier, more efficient to just figure out what the halfway point is, which is the same as finding the average. And by the way, this is not proportional at all. But you could do a little number line and figure out what number is between -5 and 3, or you could simply take -5 and 3 and add them up. So you take -5 and 3, you add them up. So 3 plus -5 is going to give you -2, and that should probably say -2 right there. And then you take -2 and you simply divide by -1, and you know that ends up giving you, -2 divided by 2, that ends up giving you -1. That means the axis symmetry is -1. So that means that the x coordinate of the vertex is -1. Now, keep in mind that only gives you the x coordinate of the vertex. We still don't know what the y coordinate of the vertex is. So to find the y coordinate of the vertex, what we're going to do in this case is simply take our x coordinate that we found, which is x is equal to 1. And what we're going to do is we're going to take our x coordinate of the vertex, which is axis symmetry, by the way, and we're simply going to sub it into our equation or our function. So we take -1 and we sub it into x, and then we end up getting, so instead of taking, so I might as well write it in function notation actually. I'm going to write 2 times -1, so 2 times -1 minus 3, and then -1 plus 5. And what I'm going to do now is simply figure out what that gives me. So we end up getting -1 minus 3, which is -4, and -1 plus 4, which is 4. And then we end up getting 2 times -4 times 4, which ends up giving us -32. So that means that the vertex, now we have the whole complete solution here. The vertex is simply going to be the axis of symmetry, which was -1, and the function at the axis of symmetry, which is what we just found right here. We found the function at the axis of symmetry, which is -32. And there is our final answer. So I hope that kind of makes sense so far, and that made it clear. So I'm going to repeat the steps. You find the halfway point between the zeros, which is basically the average. Then you take that midpoint of the zeros and the x-coordinate of the vertex, and you sub it into your function, right? So you're simply subbing in the midpoint into your function. That's going to give you the y-coordinate of the vertex, and then the final step there, simply put the x-coordinate and the y-coordinate, the corresponding x-coordinate and y-coordinate together, and you have your vertex, and you're done. So the last example that we're going to look at here is finding the leading coefficient A. So to find the leading coefficient A, it's slightly more complicated, but you're still using the same idea. You're using substitution, which is basically similar to what we just covered. So how would you find the equation of this graph here? Well, if we want to find the equation of this graph in vertex form, which is in the form of a times x minus r times x minus s, we simply identify what the zeros are first. So the zeros are -1 and 3. And we notice next that to find, now that we know what the zeros are, -1 and 3, we simply have to find out what, oh, and so obviously going back a little bit, now that you know what the zeros are, -1 and 3, remember when we put them into the factor form, we simply remember to switch the sign. So we have a times, the equation is a times x plus 1, and then it's going to be x minus 3, right? So we're subtracting off the x-intercept there. To find the leading coefficient A, we simply have to sub in another point on the graph. This is actually similar to what we have done before. We've followed similar ideas in grade 9 and grade 10, right? If you have too many variables that are unknown, which is the case here, we're trying to figure out what A is. Unfortunately, there's still a lot of things that we don't know in this equation. So what you're going to need to do is use another point on your graph to help you identify the missing variable. So what you would do in this case is simply pick another point that you know is on the graph. Is there another point on this graph that's pretty clear to read? Well, you have a couple choices, but for simplicity's sake, and what I would definitely recommend is focus on the vertex. Now I would focus on the vertex because the vertex tends to be pretty clear to find. Another point that you could have picked on as well is the y-intercept. In this case, the y-intercept would have been 0 and 6. So an x-coordinate of 0, a y-coordinate of 6. But for our case, let's use 1 and 8. So we have an x-coordinate of 1 and a y-coordinate of 8. So we're going to take the x-coordinate of 1 and the y-coordinate of 8 and sub it into our function. So we take 1 and 8 and we sub it in. So what that means is that we will replace the y right here with 8, and we will replace the 1 right here. Sorry, we will replace the y with 8 and replace the x with 1. And the reason we're doing that is because we know this x and y coordinate pair is on the graph. So we simply replace the x coordinate with 1 and the y coordinate with 8. And so this ends up giving us 8 is equal to a times 1 plus 1. And then it's going to be 1 times 1 minus 3. So all we're doing is simply replacing the x there with 1 and replace the y with 8. And our next step here is we simply simplify this. So we have 1 plus 1 is 2, 1 minus 3 is -2. By the way, when you try to find out what the leading coefficient is or what the vertex is using this method with factor form, you'll often notice that the values when you sub in a point, when you sub in the vertex is not just any point. When you sub in the vertex is going to be exactly the same but opposite signs. That's not a coincidence. It's because they are both, think about it this way. The vertex is going to be the same distance away from the two zeros, right? Or whichever two zeros you find there. So the only difference is that one of them will be positive and one will be negative, because you know that the vertex, if this is the axis of symmetry, I hope this kind of makes sense. The axis of symmetry is a line going halfway between the vertex. So it cuts in half there. So if these are my, actually, that's a bad graph. Let's do it over here. So if these are my two zeros right here, I know for a fact, and I'll call this R and S, I know for a fact that that they are both the same distance away from the axis symmetry. Really, the only difference between them is that for one of the zeros, it's going to be above the axis symmetry, which is why it's going to be positive, and the other one is going to be below the axis of symmetry. Sorry, and for the other one, the zero is going to be below the axis symmetry, which means it's going to be negative there, right? So that's why you end up getting a bit of a different answer there, right? So I hope that kind of makes sense so far. So we get, so essentially we notice we get the same value, absolute value, but just different signs there. And then when we simplify this, we end up getting 2 times -2, which is -4. And then of course, a times -4, we can simplify that by simply writing -4a. And then we end up getting 8 is equal to -4a. And then our last step here, simply divide by -4 on both sides. When we divide by -4, you end up getting -2. So my a value is 2. So my last step here, put it all together. If you know what the a coordinate is, sorry, not the a coordinate, if you know what the a coefficient is, the leading coefficient there, you simply sub it into your function. So you end up getting y is equal to -2. So instead of writing a, I'm going to write -2 because I found it now. Is -2 times x plus 1 times x minus 3. And there is your final equation. So I hope that kind of makes sense so far. So last thing I wanted to go over is how to switch between factored and standard form. We are going to talk about vertex form, by the way, and I think most of you already know about vertex form. So it shouldn't really be a big surprise, but we're going to go over that in the next lesson. Like I said, I just want to focus first on standard form, factor form, and what we know so far. So how to switch between standard form and factor form. So that's actually pretty easy, and it's kind of obvious based on the name. Factor form actually kind of tells you exactly what it is. You have to factor, right? And I'm not even going to review factoring because we spent a lot of time already factoring, and I'm hoping everyone is a pro at it now. So everyone should already know how to do that. So I'm going to write, you know this already, right? So hopefully you know that from grade 10 or grade 11. Maybe you learned that this year. And like I said, you can use any factor method that you use as long as it works for you. You can use the Aussie method or decomposition or another method that we learned. Just make sure it works for you. That's all. So if you want to switch from factor form to standard form, pretty self-explanatory. You expand and collect the like terms. So you're simply going to expand and collect the like terms, and then you normally want to write it the highest degree to the lowest degree. Okay, so pretty simple as well. So here's an example. If I want to switch f at x is equal to 4 times x minus 3 times 3x minus 5 into standard form, what I need to do here is simply expand out my brackets, and I would suggest that you expand out the two binomials first, the product of the two binomials first. That's my suggestion. It just makes it easier, I think. So you're going to take x minus 3 times 3x minus 5. You're going to multiply that first. And I showed all the work here, but you don't have to do that. So x times 3x is equal to 3x squared. And so I'm showing what we're doing there. And then I take x times -5, which is -5x. And be careful with the signs. -3 times 3x is -9x. And finally, -3 times -5 is +15, right? So a negative times a negative is a positive. Then you simplify this, you end up getting 3x squared minus 24x plus 15. And then in my next step here, I simply take my final answer here of the product of the two binomials, 3x squared minus 14x plus 15, and I'm simply going to multiply each of them by the leading coefficient, which is 4. So all I have to do there is simply multiply out the leading coefficient there of 4, and I end up getting, oops, I'll erase this so you have more space to see it. I end up getting 12x squared minus 56x plus 60. And that is my standard form of the equation. So now I look at that and say, okay, that's standard form, and I know how to work with that. So that was pretty much it for the lesson. So hopefully it was easy enough to kind of follow. Again, if you have any questions, please ask. Okay, thank you.